there are lots of theories of intelligence, and it's sort of been an ongoing, sort of complicated topic about how do we define it, how do we measure it. So we're going to go through this pretty quickly, but there's a lot of information here. Just want to make sure I cover this content because I think it's important when it comes to illustrating how psych testing has evolved over time, especially as it applies to intelligence, and see how things have changed and what are the sort of controversies and things. All right, so we're going to spend some time talking about sort of how intelligence has been defined, and then we'll spend some time talking specifically about the Stanford Bin A5 intelligence scale, and then we'll transition to part two where we'll talk more about the Wechsler scales, and just to give you an idea of the different approaches to how intelligence has been measured. So defining intelligence, like any other concept, right? We have to define things. We have to be able to give an operational definition. And this has been, a challenge. It's been a challenge in lots of areas, and psychology is no stranger to this difficulty in trying to define it and measure it. In the face of this challenge, there's been lots and lots of working definitions of intelligence that have been proposed over time. Bin defined it as the tendency to take and maintain a definite direction, the capacity to make adaptations for the purpose of attaining a desired end, and the power of auto-criticism. All right, that's the way the Bin viewed intelligence. Spearman, who's another sort of pioneer in intelligence, defined as the ability to educe either relations or correlates. It's a much simpler, way of thinking about it, but also doesn't seem to quite cover all the specifics. Gardner thought it was the ability to resolve genuine problems or difficulties as they are encountered. All right, so you can see there's sort of different takes on what intelligence might be in general. So there are many definitions, and each tends to portray a general theory followed by the researcher, right? So each researcher has some theory that they subscribe to, and you often see that sort of then come out in their theories of intelligence. So there's been three different approaches, three different research traditions in the study of intelligence. One is more psychometric, right? It's about the test structure, it's how to develop questions, how to test it, that kind of stuff. And this, it's obviously what is in this chapter. And in the book I recommended to accompany the course, they do cover other things like information processing, which is the ability to sort of learn and problem solve, and other cognitive approaches, which is about sort of adaptation and being able to respond to real world demands. We're not going to talk about these during this lecture, and it's something you can read about if you're interested, but it's not going to be a part of the material that I cover in here. Okay, what brought about this idea of intelligence testing? And I mentioned this in the very intro lecture for the class, but let's sort of cover that again. So in France at the end of the 19th century, the French minister made a controversial decision to try to identify intellectually limited children in order to remove them from regular classes. Now, it sounds bad, I'm going to remove them. Well, they wanted to, and it has been a tradition for a long time, and which there is sort of movement now away from it, but is to try to put them into specialized classes where they can receive extra attention. So that's why I say supposedly, so they can receive specialized training to help bring them up to the intellect of their same age counterparts. All right, that sounds good. Let's bring them out of what they call like the mainstream, population of students, put them in special courses, give them special attention, and help them catch up. All right, sounds like a plan. Right, but if I want, the idea here is if I want to be able to do that with children who need extra help, I have to be able to identify them first. Okay, so in 1904, the minister appoints a committee to recommend a procedure for identifying intellectually limited children. Right? I'm using these sort of terms carefully. Right? These are not students necessarily that have intellectual disabilities or are not able to function at their peer levels. At least that wasn't the initial threat of this. They were looking for kids who were behind but with extra help could catch up. All right, so this has been broadened out to lots of other cases, but I think that was the initial goal. Okay. So there's two early principles they're interested in. One was sort of age differentiation, the idea that if you're going to identify kids who are behind, you then now had to define what was behind. So if they're behind by what? So if they look, so one can differentiate older children from younger children based upon their mental capacities, meaning that older kids know more things, can understand things better. They just have more knowledge, more skills, more practice. So you should be able to differentiate kids by age. Older children have greater skills than younger children. So they wanted to develop this idea of being able to give students or respondents a mental age. So knowledge and task ability for a specific age group. So they can figure out what the average 9-year-old knows and their average skills. And then we could figure out if a child fits that mental age. And if that kid is 9 and they have a mental age of 9, well, they're perfectly normal. They're of sort of average knowledge and skill. These abilities were assessed and each respondent compared in the past. Meaning, so they would look at the kid's mental age, look at where their other sort of age mates, their other students in a same age group, and see where they were. Today, this isn't quite done. Mental age is not really quite still in there. They just use, IRT is used to calculate ability levels, and they do things by percentile and other things. It's more mathematically complicated, but in the end you still get an IQ, but that IQ is not necessarily based on mental age in the same way that it used to be. Right. And then the other principle was this idea of general mental ability. So intelligence may be composed of several individual factors, but Bin A and lots of other people he was interested in measuring the sum total of all of them. They weren't interested in trying to break things out by different types of skills and abilities and knowledge. They just wanted a general idea of intelligence. Right? So that's why when regional scales came about, there was just one score. Right? You had one IQ, that was it. So this idea of general mental ability was first proposed by Galton, and we discussed him a little bit. And he, if you remember, was the cousin of Charles Darwin. Right? So, and he had one of the first sort of psychometric labs and stuff. So this idea that there was this idea of hereditary genius that there was a book he had published, and he was interested in this idea of trying to find out what was general mental abilities, and also looking at the variety of individual differences people had on a number of things, including things like intelligence. Independently, there was Charles Spearman, which you may have come across the name because of there's like the Pearson correlation. There's also a Spearman correlation, and he had a lot to do with things like factor analysis and intelligence. And intelligence, he again put out this idea that intelligence consists of one general factor. So think about factor analysis. One factor really explains all of it. If you're intelligent, it's going to explain really all the questions on an intelligence scale. But there are also a large number of specific factors that you can get into, like math ability, visual, spatial, other things that you could do. But there was this idea of a general intelligence. So that's partly that's because if someone is typically talented or if they have high abilities in one area, they typically, not always, will have have higher abilities across other areas as well. Maybe not all of them, but there tends to be some correlation between the specific factors as well, which is why Charles Spearman and lots of other people believe there was just this one thing, that intelligence was this sort of monolithic. Right? It was a unidimensional sort of idea, even if it had some sub-factors and other things that existed within it. It was still a single entity. Okay? So Spearman developed this idea around intelligence where there was something called the Spearman's G, and G stood for the general factor. So G is basically general intelligence. G acts like a single general factor. The higher someone scores on G, the higher they are on the specific intelligence as well, right? So they have to be, in order to be sort of high on the general intelligence, you got to be fairly high on all the other specific ones too. Approximately 50% of the variance in a set of diverse mental tests is represented by this single general factor. So that's one of the, he used, factor analysis and a number of other things to show that you could really, account for quite a lot of the variation across people in the responses to mental ability testing, things like intelligence testing, with just a single factor. Like at least, approximately 50% of it could be explained just by this single thing. Spearman developed factor analysis because he noticed that most seemingly unrelated abilities were positively correlated. Right, so it's an interesting idea that I think of something like, I don't know, music ability and math ability can come up and show to be correlated with one another, when most people I think would assume that they aren't, that they seem like unrelated things. So when he started to notice this, he started to develop these sort of mathematical models to explain how things were related, and that's really the early early development of factor analysis. He also called this idea sort of positive manifold, that being intelligent, so spread out through many of the different specific intelligences, and things that would seemingly be unrelated are related because of the person's general intelligence. So sort of this idea of positive manifold. Okay, graphically, you can think about this as here is a general measure of intelligence, this idea that it's one thing. Then you got all these sort of things measuring specific different skills, and these really could be also circles in the sense of that this could be like verbal ability, and this would have multiple items or multiple questions. But let's just say this is like a verbal ability item, a math ability item, that all these things that would seemingly be unrelated, meaning that, you might not think that someone's verbal ability and math ability, or that somehow vocabulary and spatial relations would be related. But what we found is that, extracting a single factor to explain the seemingly unrelated skills and sort of sub-intelligences, these specific intelligences, would actually explain a good deal of the variation between them, and they actually were fairly consistent in scoring. So, but there were other theories, and in direct contrast to Spearman's G theory, there was Howard Gardner's theory, which has gained a lot of. I think people like this theory of intelligence because it doesn't require you to be generally intelligent. You actually can be intelligent in different areas. So where Spearman tried to explain the specific intelligences, these skills, as being sort of subcomponents of overall intelligence, Howard Gardner went the other direction and said, look, they're just different types. There are different brands, different ways in which people are intelligent, and he put them out there. He said there are 8 different kinds. You have like linguistic intelligence, which is the ability to use with clarity the core operations of language, right? So someone who's like a politician or someone who speaks for a living or as an orator or something like that would be high in sort of linguistic, right? So logical mathematical, which, this seems to line up with our idea of sort of math ability. So logical mathematical is logical, mathematical, and scientific ability. So someone who's like a scientist would likely be high in this intelligence. And then you get things that people, I think before Gardner, really didn't think about as intelligences. So there's two different types of intelligence, I think, that most people wouldn't consider intelligences, that it really had to do with sort of navigating your sort of internal and external life with other people. So one of them is intrapersonal. It's the ability to form an accurate model of oneself, to be able to understand, be really good at introspection and things like that, where someone like a therapist or novelist really has to understand the sort of human condition and who they are and that kind of stuff, to really be able to help other people and to be able to accurately represent people in works, in written work and things. The counterpart to that is interpersonal intelligence, which is the ability to notice and make distinctions among other individuals' moods, temperaments, motivations. So these are people who are really good at reading other people, can navigate social situations well. They really understand what motivates people and are able to use that information to help them or whatever. or to help themselves sometimes. So people like, politicians, religious leaders, and therapists, they need to really understand people and be able to if they're going to be successful, they have to be able to do those things. And then you get, again, things that people generally wouldn't have thought of as a specific intelligence until sort of Howard Gardner's theory came along. This idea of musical ability. Now you can have someone who is very musically intelligent, but really have none of the other intelligences. I don't mean that they have none, but they're not high. So someone can be very musically skilled, talented, and seem to have a natural sort of ability for music, and not necessarily be high on other areas, which is what sort of led Howard Gardner to think, well, these things were really separate intelligences, not just underneath one global intelligence. So there's the ability to use the core set of musical elements, pitch, rhythm, timbre, that these things like musicians, singers, composers, all of them would have to be skilled at this. Then you got spatial ability, the capacity to perceive the world accurately and to recreate one's visual experience. So this is something that is an interesting one. So and a lot of visual spatial stuff comes up in these other types of intelligence tests and things. But this is an interesting one where it's the idea to be able to keep an accurate visual representation of your world. They could show you a picture of, say, this is the little remote that I use. They could show you a picture of the little remote, and then they'll ask you they'll give you other pictures, and they'll say, okay, well, which of these other pictures could be this object, oriented in a different direction, right? So you might have a picture like this. They'll show you some other pictures, and you have to be able to decide, all right, if I was able to rotate mentally this picture, what would that look like? And people that are good at that are sort of high in this sort of spatial intelligence. If you're someone who, like an architect or something, where you have to visually represent, large houses or buildings on paper, you'd have to be good at something like spatial intelligence. Then you get this sort of bodily kinesthetics intelligence, which is, again, not something people would have thought of in the typical general intelligence, but this idea that control of one's body motions, the ability to handle objects skillfully. So actors, dancers, acrobats, athletes, these people who are skilled at these sort of the kinesiology, the kinesthetic components are all going to be sort of high on this sort of bodily kinesthetic intelligence. And you got this last one, naturalistic, the ability to comprehend, classify, and understand things encountered in the world of nature. So you've heard of people, people have a green thumb, right? People that seem to, they can really do no wrong when it comes to growing things, or to raising animals, or to caring for for smaller creatures and things. So farmers, ranchers, animal handlers, zookeepers, veterinarians and stuff, all these people that would have to be able to have a good understanding. Even people that are just have gardens, and whether they're growing, they're getting a high yield of tomatoes and just things like that. The people that seem somehow to naturally know what these plants or animals and things need would be high on naturalistic intelligence, according to Howard Gardner. All right, so then there's, again, multiple theories. There's Horn and Knoll in 1977 or whatever. They came up with this sort of GF versus GC. So it really comes down to they talked about fluid versus crystallized intelligence. Okay, and this is still a language that gets used quite often when we talk about when growing up, younger children up through probably middle aged or something like that. You have a high level of sort of fluid intelligence that tends to sort of taper off and is replaced more with sort of crystallized intelligence, even though you sort of have both of them. So fluid intelligence is those abilities that allow us to reason, think, and acquire new knowledge, allows us to learn new things. So it's fluid because it's always changing. So it's the idea that it's an intelligence that allows you to continue to grow your intelligence, grow your understanding, which is necessary when you're younger and as you're growing up. As you acquire more and more knowledge, and that knowledge becomes sort of more permanent, and it isn't changing so much anymore because you've reached an understanding and now you're not really trying to adjust your understanding anymore, that type of intelligence becomes more crystallized. So it's knowledge and understanding that we have acquired that is now sort of static. Okay? That's why it's crystallized. It has no longer fluid anymore. It is no longer changing. It's now becoming crystallized. It's sort of combined wisdom. And you can see this idea becomes interesting because the adage of like you can't teach an old dog new tricks sort of matches up in this, where as people start to rely more and more on crystallized intelligence, their intelligence is no longer as fluid, which is why it's as you get older, it's tougher to learn new things, it's tougher to adapt, it becomes more difficult to sort of change, which is why you may be on, if you're on like a phone call with a parent who doesn't understand how to use a computer program or something like that, and something that seems very easy and very straightforward for you is really complicated to them, and they can't really get it. And it's because they, according to Horn and Knoll, it's because they're now relying on more crystallized intelligence. They're relying on what they already know, and the ability to adapt and have fluid intelligence is actually sort of tapered off, and they rely more on this sort of crystallized form of intelligence. We're going to spend the last part of this sort of section talking about the Bin A scales. Now it's referred typically as the Stanford Bin A, but it started off as the Bin A and Simon, but let's talk about the sort of the growth and change and all this other stuff that has happened. And it's likely that there has been more change since this, but we'll talk about at least up through the Stanford Bin A5, and you can get an idea of how things changed and grew over that time. Alfred Bin A, again, remember, it was early 20th century, was asked to create some kind of test that could gauge, differentiate between this general mental abilities of children of different ages. So they wanted to use mental age, and the idea that really intelligence was a single thing, right? So the first version of that came out along in 1905. It then sort of split up where it went one direction. I forgot where this is, but it went in one direction, and some other people started developing a different version. But then it got imported over into the United States in about 1916, and that's when it changed over to the Stanford Bin A. So the Stanford Bin A1 was developed in 1916, and I think a lot of that process was just translating it and making it work with in English with American respondents. It then went through some revamping and changing along the way. Where in 1937 it got updated to the Stanford Bin A2. In 1960 and again 1973, it got revamped again to the Stanford Bin A3. It got revamped again in 1986, and then again in 2003. So you see the sort of progress. It keeps getting changed and added. A lot of it's because as time goes by, language changes somewhat, and what people actually know. Because if you're talking about using a 1916 version of general knowledge, well, it's not going to include things like computers or calculators or things. So as time goes on, things start to become dated, and they have to be updated for at least that reason alone, and there's other reasons why they've been updated too, which we'll talk about. So the Bin A scales begin with a unitary G model. So they're in the same model with Spearman. There were 30 items. It was put on an age scale. There were 3 levels of an intellectual deficiency. So these were terms that were used. These were they weren't medical terms, but they're like the official terms, right? So if you were in the most severely impaired group, the actual label was idiot. And then if you had moderate impairment, you were an imbecile, and if you were just mild impairment, you were a moron. So I guess the next time someone calls you a moron, you can at least be like, well, at least he doesn't think I'm an imbecile or an idiot, right? The problems were the question of unit, like what are these sort of mental age things actually, how does that work? It becomes a little hard. They only had a small normative sample. They only used 50 children to really norm it, and it had limited validity. So it was a good start, but it wasn't quite where they wanted it to be. So in 1908, the age scale continues. They're still talking about, they start looking into this idea of mental age. That if you know as much as a 10-year-old, then your mental age is 10, right? Describe the level which an individual could reach on the 1908 scale. Mental age was now the description of the level you could reach, right? So the higher mental age, the sort of more intelligent you were. So if you can perform tasks like answer questions that can be performed by 2/3 or 3/4 of an average 10-year-old, then you get a mental age of 10. Right? It's pretty simple. It tells you sort of where you match up with other responders. still, the problems with a single score and heavy verbal requirements, right? Because these were still scales or tests that you had to do a lot of reading. Like there were questions, you had to read like scenarios and answer questions. So 1916 was when it came to the United States. And at Stanford, which is why it became the Stanford Bin A5. So they increased the standardization sample, although there was an issue where all the children in the sample were white native Californians. So if you're talking about what your average person knows or understands, well, they're really only getting a small window. What do white Californians know? And you're being sort of compared to them, which is problematic. They retained the notion of age differentiation and sort of retain the notion of mental age at this point. It's at this point, 1916, that they started to take the mental age that you could get as part of the test, and they started to compare that to chronological age. And it's this improvement that really made a big difference to people's sort of, I think, acceptance or reliance on this as an intelligence scale, and it's become very, it's almost, it's hard to think about it not being this way anymore, where the idea is if you have a mental age, right, and you divide that by your chronological age, then multiply that by 100, and you now get an intelligence quotient. So it was at this point that it started being a quotient that actually is similar to what we know now. So the way that works is if I'm 10 years old, if I get a mental age of 10 on the Stanford Bin A, and I am 10 years old, well, it's going to be a 1. So 1 times 100 is 100, which is why this is considered sort of average IQ. Because at 100, it really indicates that you know as much as someone your age knows. That's what an intelligence of 100 actually indicates, your average. Okay, so how mental age, and it really was not until this 1916 in the Stanford Bin A version that this really started to come out. So the problems here that, this was still that they're trying to bring and adapt it to the United States. Test topped out at a mental age of 19.5. So they really only had samples that were, children through adolescence, maybe young adulthood. Everybody older than that would produce some kind of mental retardation, because their mental age would top out at 19.5, and their chronological age would continue to go up. So it would look like, well, you only know as much as a 19-and-a-half-year-old, but you're 40, right? So it's going to look like you're in one of those imbecile, idiot, moron categories. So typically any mental age above 16 would be set at 16. So even if I were 40, it would give me a mental age of 16, because there was a belief at that time that mental age, your ability to sort of mentally grow, mental age, maxed out at 16, which actually makes this even worse, right? Because as you're getting older, your age is even younger. It's not 19.5, it's 16. So 1937, they decided to do a larger standardization sample to sort of, to broaden out the range they could work with, and also just to have a better, more inclusive sample to sort of compare to. So there were 11 states in the standardization sample. There were more urban subjects than rural. Only whites included in the standardization sample, and that may sound racist or something. I mean, I don't think that was the intention, but I think even unintentionally it sort of came out that way. That it was just typically those were the people that were more readily available. I think it was really more about convenience than it really was trying to avoid, ethnic minorities or something like that. And it doesn't say it here, but I'm gonna assume that not only were they mostly whites or all whites in the sample, they were probably mostly all male as well. Just because if you look back at most of the research done for many of the years in that century, almost all of the studies relied upon middle-class white males were like the typical respondent. So the other big change here is they had alternative forms, the L and M forms. The problems here is that different standardizations at each age for the standardization sample. So before, we talked about, that generally intelligence has about a 15-point standard deviation. All right. Well, the standard deviation at 6 was a lot less. It was like 12.5. As you went up to 12, it started to get to range more at 20. So the IQs at different ages were starting not to be so comparable anymore. So that became a problem. They were no longer in this standardized scale that could be compared across different ages and age ranges. So in 1960, both forms of 1937 test combined to produce the Stanford Bin A5 version, and it introduced the concept of a deviation IQ. So if your mean is 100, deviation 16, okay, deviation IQ determined by how far above or below the mean a person scored within a particular age band. So it started to look at how many standard deviations you were away. Instead of just looking at mental age, it started looking at, all right, well, we can actually start to standardize this based on how far away they were based on their standard deviation, or how many deviations there were from the mean. 1960 norms were better. They're still all white, but they were larger. And in 1972 was renormed, included for the first time in non-white standardization subjects in 1972. 86, 2003, Stanford Bin A intelligence scales, the 4th and 5th editions. They revised items. The structure became more hierarchical in terms of the questions, in terms of difficulties and things. No longer depended upon a unitary intelligence construct. So they moved away from this idea of one intelligence, even though you still got a single IQ scale. You now are given scores on multiple other things as well. It was theoretically more linked to that sort of fluid, crystallized, and multiple intelligence model. They started to build some of those other things into it. There was one called Thurstone's multidimensional model, where intelligence is made up of primary mental abilities, and these abilities in turn are driven by G. So this is what it says multidimensional, but it's also sort of hierarchical, where you have the sort of questions on the exam. Those are explained by the specific abilities, like with Spearman, which in turn were explained by this general intelligence. So there was more of a hierarchy to how intelligence was sort of put together. So now you can get scores on these specific strengths, these primary mental abilities, and then in turn also get a general IQ score as well on these versions of the Bin A scales. So here you have the hierarchical structure of the Stanford Bin A4. You had general intelligence, and general intelligence was really built upon working memory, quantitative reasoning, verbal reasoning, and abstract visual reasoning. So it's still not to the point of having 8 of them like Howard Gardner's scale, but we still are now trying to build upon. You can see how this has influenced lots of things, because the SAT, the big focus is on verbal reasoning and quantitative reasoning. Those are the 2 main sort of things. Same thing with the GRE. Lots of these sort of tests have these 2 as a big component of looking at your abilities. So there are now a number of sub-tests as part of the Stanford Bin A4. And they were these sort of routing subtests used for adaptive testing. So 1986 used to test knowledge of words and their meaning. Highest level attained of vocabulary test indicates starting point for remainder of tests. So they were called routing tests because instead of giving you, this isn't adaptive in the same way that I was talking about computer adaptive. It's adaptive in the sense of you basically took a pretest. They call a routing subtest. You took a pretest, and how you scored on that test then told them sort of where to start you in terms of the difficulty or the targeted age range that you're supposed to get at, and then the rest of it sort of then went from there. This is used to gauge age group for the test, and they looked at vocabulary loads highly on the general factor. So a big part of what is driving the general factor is vocabulary. So they would use that a lot to sort of start people off of where they were in terms of their general intelligence. Now, in 2003, the big difference, and this was, I think, the influence of the competing scale we'll talk about later, the Wechsler, where, again, the Stanford Bin A was all verbal, was all reading. You had to be able to read and comprehend the language. So in 2003, it was the first time they actually added a non-verbal routing subtest, where there were tests that didn't require you to read or require verbal understanding, that you could be routed towards intelligence based on non-verbal tests. Once these sort of routing subtests, right, were used to place you, and your age range was sort of established using the test, that you can then sort of put someone on a better track towards what they're sort of giving some long tests that covered all the different possibilities of age ranges. You can actually then start them off at a better place. This helped to choose a level for the remaining items, like it gives you a start point. And then they had different terms, like the basal level is a level at which a minimum number of correct responses is obtained. And then you had a ceiling level, which the number of correct responses indicate that the items are too difficult. Okay, so they started to use this terminology to figure out where to sort of place people and what the sort of the minimum and maximum numbers were to sort of get somebody into the right age range or age group. They started to do, again, some non-verbal things like bead memory. There are 2 levels. They had single and double bead displays for younger children and sequential displays for older individuals. Basically, they would show people beads in a particular order, and they had to replicate the order that the bead like colors and patterns were in. Used to test visual short-term memory. And so we show them, take it away, and they say, okay, give us back the order of the beads. And they also had a quantitative subtest. Items presented visually, and subjects responded verbally. So this is one where, again, the test has to be administered because they're given, they're shown a problem or something like that, and they had to then tell the person what the answer was. So scrap paper was permitted and used to test quantitative skills, like how good you were at things like mathematics. There was a memory for sentences subtest. So again, test auditory short-term memory. Sentences are presented verbally, so the person would say the sentence to them, and then they had to repeat the sentence back. They had pattern analysis. This is, again, visual, spatial, motor skills. There was arrays of blocks presented visually, and then blocks must be assembled by hand to match the original pattern. Like, could you match the pattern? And the patterns were just more complex as the targeted age range sort of went up. You had comprehension. It's not a test of reading comprehension, but a test of social and moral reasoning. So again, items were presented verbally and then must be answered verbally. So they give them like a scenario, and then they would ask them sort of how they would navigate that, or what they would do in that situation. It was sort of test their social and moral reasoning. Then you had the absurdities subtest. This is another test of social logical reasoning. But they were given things that would seem absurd, and then they had to sort of discuss them verbally. Then you had sort of digit memory, where you look at there's 2 subtests, digits forward, digit backwards, but both scores are combined for the subtest score. This taps short-term auditory memory and active working memory, because I believe they would tell them numbers and then they repeat the numbers back. And the forward is they would say, all right, repeat these numbers, and the backwards they would say the numbers in an order, and then the person had to repeat them in the reverse order, repeat them backwards. So it required them to sort of hold the numbers in memory and then repeat them back. Yeah, copying was another subtest. There were 2 levels: copying blocks for young children, paper and pencil for older children. So test visual motor integration and visual spatial skills, and another one where you're given a pattern and you're asked to sort of replicate it. You have memory for objects. This tests sequential visual short-term memory. Again, they would show them objects, and then they would ask them to repeat back what they were. And then you had matrices, which another subtest that tests nonverbal logical deductive reasoning. So we're sort of solving, puzzles, matrices of puzzles that they had to solve. Number series. This tests quantitative and logical deductive reasoning, and scratch paper was allowed. Again, another way of looking at numbers instead of being told to them and repeated back. It's just a different form of deductive reasoning using numbers. You had paper folding and cutting. Sounds weird, but it's, test visual spatial reasoning. No actual cutting occurred in actual test items, only for sample items. The idea was they would show them something, and then they would be asked to sort of replicate the paper and how it's folded in order to test their sort of visual spatial manipulation. You got verbal relations, which I imagine something similar to like on the SATs, like the analogy sort of questions, things like that. So test verbal logical reasoning. You got equation building, which again something that tests quantitative, logical, deductive reasoning skills and active working memory. So this is now getting at memory, it's getting at math, it's getting all kinds of things all at the same time. So how are these subtests scored? Well, items on each subtest are administered to obtain basal and ceiling measures to try to figure out what was the lowest number and the highest number. And the highest number of item administered minus number of failed items equals their raw score. So they would administer, the question in terms of difficulty, and they figured out the highest difficulty in which they could sort of respond. They would take the number of items they administered in there, subtract their failed items, and get a raw score. And then raw scores were converted into standard age scores with a mean of 50th generation of 8. And then those could be then converted to IQs. Subtests are then, then they can be combined for area scores, and all that stuff combined then became IQ. Okay, so you can actually get a different age score, standard age score, on the different areas, and show that you're higher in age in one area and lower in others. So they had, these are the 4 scales we saw earlier. That for verbal reasoning, they would combine the vocabulary, comprehension, absurdities, and verbal relation scales. For abstract visual reasoning, there was a pattern analysis, copying, matrices, paper folding, and cutting. For quantitative reasoning, it was the quantitative number series and equation building. And then for short-term memory, it was bead memory, memory for sentences, memory for digits, and memory for objects. Basically all the sort of memory items were all put into the short-term memory area, which is interesting to think about it, because really your intelligence does require a bit of short-term memory to be able to manipulate ideas or numbers and things to be able to respond accordingly. So it's interesting that here we're looking at a subscale that tests specifically short-term memory, and it's easy to think that someone who is potentially bad at this area, that could affect them being not so great in some of these other areas. Scales and scores. There are 4 scales. Each produce their own area score. So there are 4 area scores, and those were then combined to produce a test composite, an overall score, which was then fixed to have a mean of 100 estimation of 16, which is really close to somewhat 115 before. So this is now these typical numbers you see related to intelligence scales like the Stanford Bin A5. So the advantages of the Stanford Bin A4 was it's based on more modern theories. So it allowed intelligence to be treated more, in a more complex way, in a more modern way. It brought in the more tests of sort of a wide range of intelligences, not quite the multiple intelligences of Howard Gardner. There wasn't 8 different ones, but it did build upon foundations for the fluid crystallized intelligence, and it tested a more wide range variety of intelligences with the 4 scales. You could test a wide range of ages with a single instrument because of the routing scores, right? You can test as young as 2 and as old as adulthood, because you're able to route people to different sort of subversions. It had strong reliability and validity, and it became a lot more sensitive in higher end of abilities. Better, you're able to discriminate people who are of high intelligence better, like among gifted individuals. You can actually start to tell them apart because the scale was more sensitive to that. And again, like I mentioned before, this tests short-term memory more explicitly, which in the past it hadn't. And again, because if someone has issues with short-term memory, it's likely to impact the rest of their intelligence. So they were starting to address that more directly. Okay? Some disadvantages is that the age scale got sort of eliminated for more of a point scale. So instead of just being really an age, like your mental age, it became these sort of standardized scales. It's sort of more of a cumbersome test. Taps many areas, requires testers to be facile in 15 different scales, does not require testers to obtain basal and single measures on all 15 tests. So it wasn't quite consistent across all how it all worked. There were still these possible ethnic, social, economic biases because of the standardization process and stuff still wasn't quite where it's supposed to be. And older norms other than other children-based tests at present, which if you're looking at other tests designed for children, these one actually required, was based on older children. The norms were older, and it's not quite as modern, or at least at present, compared to the Wechsler scale in terms of their norms. Again, this also may not be true anymore. This may be a little bit dated. So for the Stanford Bin A5, they branched out a little bit further, some other stuff, and again, really started to directly look at things like the fluid versus crystallized stuff. They still had an idea of general intelligence. They weren't going to give that up quite yet. Actually, they still haven't. You start looking at things like fluid reasoning, knowledge. You still had the quantitative reasoning, visual spatial reasoning, and working memory. Right, so those things were there, but instead of just being, you notice that there's nothing that sort of says verbal, right? It's like verbal reasoning. They look at general knowledge and your more analytic sort of reasoning skills, fluid reasoning, and the rest of these sort of are the same. But now, each of the subscales, the structures, had both non-verbal and verbal components. So we weren't relying on some to be verbal and some to be nonverbal. Each of them now has a verbal and nonverbal component so that it's more consistent across. Okay. So the idea is that there is this full-scale IQ, which is the thing up here. So now G now is starting to be called full-scale. Full-scale IQ really was a product of a person's non-verbal IQ and verbal IQ, and that those are being driven by the different things, like the fluid reasoning and knowledge, that those were part of both their nonverbal and verbal IQ, and someone who's truly has a overall general intelligence is going to be good, across the board. And some people might be higher on nonverbal, some people might be higher on verbal, but it's a way of thinking about it. So that's what all these things are saying down here. This is the sort of hierarchical structure. There really were two of these sort of sub-factors are based on the verbal and nonverbal. It was the way you took the test, the types of items, and each of them are represented by the same areas on both sides. You just had two different versions, and everyone took both of them, and you're able to sort of look at their full-scale IQ by combining the nonverbal and verbal versions. Okay. So in 2003, they started adding more nonverbal routing tests, like IE matrices, in addition to the vocabulary test, to make sure that as they were routing to the right sort of age and sort of getting to a good starting point for the test, it wasn't just based on verbal. They wanted some nonverbal routing tests in there as well. Contains many of the subtests of the Stanford Bin A5, but they have been altered and some of them combined. It represents abilities assessed by all former versions of the test. And the 5th edition reintroduces the Agescale format for the body of the test. It's because people, I think, had gotten used to that and they sort of brought it back. So they're presenting a variety of items at each level of the test, intended to provide a variety of content to keep examinees involved in the testing experience and to allow for the introduction of developmentally distinct items across the levels. The point system was also retained, so even though they brought back this sort of idea of age scales, they also retained the point scales, which made it more complicated, but it also meant that there were just multiple ways in which the information could be used depending on who was trying to interpret it. Right? The short-term memory was shifted over to a working memory model. The other subscales remain essentially the same, except the addition of visual spatial reasoning and a few changes to the names of the other subscales. Well, for the most part, it went from 15 down to 10, because some of them were combined together. So this is how they were combined. So visual spatial is new. Abstract, visual reasoning, what they had before, they now renamed as sort of fluid reasoning. What was before verbal reasoning was now rebranded as sort of knowledge. Quantitative remains sort of the same. Working memory stayed the same. Short-term memory now took on a different flavor in terms of being more about working memory, not just short-term, but it was similar memory subscale. The 10 subscales, before. Again, because they were trying to line everything up, so there was two for each one. Had subscales that were, matrices, analogies, recognize absurdities in pictures, right? Vocabulary, quantitative reasoning, verbal quantitative reasoning, form board, positions and directions, block pattern memory, sentence memory. These are now those 10 sub-scales of the test that all then sort of folded up to the 5 scores, which then in turn folded up to the general intelligence score. So these are the form boards. Right, it's this idea of being able to place, so you see the person's blindfolded and they got to sort of feel around and be able to sort of place objects in the right place, be able to sort of figure out where things go. It's a visual spatial manipulation sort of task. It seems like it'd be super easy. It's harder than you might think just because you're blindfolded and have to do everything sort of by touch, but no, so those are form boards, which was introduced in this Stanford Bin A5. The Stanford Bin A5 information, so they changed it to using a standardization of 15 instead of 16. So that's what a 15 was coming from. I thought I remember 15. Much more game oriented, right? So they used more toys. They were brightly colored. They were trying to, like we talked about with a bit with test administration and interviewing a little bit, is that rapport is good. It helps to sort of keep the person's being examined sort of interested, especially with dealing with kids. Having the test items incorporate toys and brightly colored objects, things that kids are going to be more oriented in, you're likely to get a better response. It tapped into extreme intelligences. We can actually try to get intelligence as low down as 2 all the way to 85, to end of life, essentially. And they standardized by a stratified sample of 4,800 respondents. So stratified meaning that they identified strata, different types of people, different stratifications of people, and they went through and sampled people from each of those strata so that they're all represented. I don't have it here, but I'm assuming that means they were trying to make sure that they were covering, representation from men and women, from different ethnic groups, different. I don't know. I don't remember what the strata are, but they may have targeted different social economic status groups, all kinds of things. So it depends on. I don't have it here what the strata are, but at least they tried to stratify it instead of where in the beginning they were just using the readily available sort of white males that happened to be around the Stanford University at the time. So the standardization process got a lot better. It's more complex, but also more representative. Then reliability, the Fullscale IQ reliability is 0.97, 0.98 for each of the age ranges, and that's good. I mean, that's huge. So it's very stable. It's very reliable. Average reliability is for the 3 IQs, meaning the nonverbal and verbal IQs, plus full scale. They're all really high: 0.95, 0.96, 0.98. Those 5 factors, or 5 scores that we get, all have reliabilities of 0.9 to 0.92. Test retest is, sometimes not as great. You get down to 0.7s, but somewhere usually between the 0.7s and 0.9s, which is pretty good. And in the manual for it, there's all kinds of evidence for supporting its validity as well, and sort of matching it to other measures of IQ and other criteria and things.